Hello world. Today I'm going to talk about the colonization of Mars. The hypothetical colonization of Mars has received interest from public space agencies and private corporations and has received extensive treatment in science fiction writing, film, and art. Organizations have proposed plans for a human mission to Mars, the first step towards any colonization effort, but no person has set foot on the planet. However, landers and rovers have successfully explored the planetary surface and delivered information about conditions on the ground. Reasons for colonizing Mars include pure curiosity, the potential for humans to provide more in-depth observational research than unmanned rovers, an economic interest in its resources, and the possibility that the settlement of other planets could decrease the likelihood of human extinction. Difficulties and hazards include radiation exposure during a trip to Mars and on its surface, toxic soil, low gravity, the isolation that accompanies Mars' distance from Earth, a lack of water, and cold temperatures. The most recent commitments to researching permanent settlement include those by public space agencies, NASA, ESA, Roscosmos, ISRO, and the CNSA, and private organizations, SpaceX, Lockheed Martin, and Boeing. Since the 20th century, there have been several proposed human missions to Mars both by government agencies and private companies. All of the human mission concepts as currently conceived by national governmental space programs would not be direct precursors to colonization. Programs such as those being tentatively planned by NASA, Roscosmos, and ESA are intended solely as exploration missions, with the establishment of a permanent base possible but not yet the main goal. Colonization requires the establishment of permanent habitats that have the potential for self-expansion and self-sustenance. Two early proposals for building habitats on Mars are the Mars Direct and the Semi-Direct concepts, advocated by Robert Zubrin, an advocate of the colonization of Mars. SpaceX has proposed the development of Mars transportation infrastructure in order to facilitate the eventual colonization of Mars. The mission architecture includes fully reusable launch vehicles, human-rated spacecraft, on-orbit propellant tankers, rapid turnaround launch/landing mounts, and local production of rocket fuel on Mars via in situ resource utilization, ISRU. SpaceX's aspirational goal is to land the first humans on Mars by 2024. Earth is similar to Venus in bulk composition, size, and surface gravity, but Mars' similarities to Earth are more compelling when considering colonization. The Martian day is very close in duration to Earth's. A solar day on Mars is 24 hours, 39 minutes, and 35.244 seconds. Mars has a surface area that is 28.4% of Earth's, which is only slightly less than the amount of dry land on Earth, which is 29.2% of Earth's surface. Mars has half the radius of Earth and only 1/10 the mass. This means that it has a smaller volume and a lower average density than Earth. Mars has an axial tilt of 25.19 degrees, similar to Earth's 23.44 degrees. As a result, Mars has seasons much like Earth, though on average they last nearly twice as long because the Martian year is about 1.88 Earth years. Observations by NASA's Mars Reconnaissance Orbiter, ESA's Mars Express, and NASA's Phoenix lander confirm the presence of water ice on Mars. Conditions on the surface of Mars are closer to the conditions on Earth in terms of temperature and sunlight than on any other planet or moon. In 2012, it was reported that some lichen and cyanobacteria survived and showed remarkable adaptation capacity for photosynthesis after 34 days in simulated Martian conditions in the Mars Simulation Laboratory, MSL, maintained by the German Aerospace Center, DLR. Some scientists think that cyanobacteria could play a role in the development of self-sustainable crude outposts on Mars. They propose that cyanobacteria could be used directly for various applications, including the production of food, fuel, and oxygen, but also indirectly, products from their culture could support the growth of other organisms, opening the way to a wide range of life support biological processes based on Martian resources. Human survival on Mars would require living in artificial Mars habitats with complex life support systems. One key aspect of this would be water processing systems. Being made mainly of water, a human being would die in a matter of days without it. Even a 5 to 8% decrease in total body water causes fatigue and dizziness, and a 10% decrease physical and mental impairment. A person on Earth uses 70 to 140 liters of water per day on average. Through experience and training, astronauts on the ISS have shown it is possible to use far less, and that around 70% of what is used can be recycled using the ISS water recovery systems. Similar systems would be needed on Mars, but would need to be much more efficient since regular robotic deliveries of water to Mars would be prohibitively expensive, The ISS is supplied with water 4 times per year. Potential access to in situ water, frozen or otherwise, via drilling has been investigated by NASA. Various works of fiction put forward the idea of terraforming Mars to allow a wide variety of life forms, including humans, to survive unaided on Mars' surface. Some ideas of possible technologies that may be able to contribute to the actual terraforming of Mars have been conjectured. That's all for today. Thanks for watching.